All right, so the thing is, we really need to figure out what this is. I think I'm going to show you two different ways here. K is the thing that's changing. So I'm going to check this. I think I can check this on my calculator. I didn't even try this beforehand, but I'm going to check this on my calculator. So we'll do the 4 plus. But we got to figure out what this stuff is. So if I plug in 2 for K, I get 3 times 2 minus X. And then I'm going to add 3 times 3 minus X, right? Isn't that what this is? Plus 3 times 4 minus X. Plus 3 times 5 minus X. And this is 6 minus 3x, 9 minus 3x. Oh, that 3x was repeating itself, huh? 12 minus 3x and 15 minus 3x. So it's minus 12x, so it can't be one of these two. There's 4 minus 3x's. Now I just got to add these up. 15, 27, 36, 42, 46 looks like the right answer. 46 minus 12x. There it is. For some reason I had in my head that it was choice 3. I'm wondering if I could use my calculator to check this. So I'll go here and I'll go back into this summation and we're going to use K, and they're going from 2 to 5, and it is 3 parenthesis K minus. Now I'm just going to pick any value for X here because otherwise it will give you some random thing, and I'm going to pick 10 for X. It just makes it easier. Whatever value you pick for X, we're going to pick 10, and we get negative 78. So if that's true, I should be able to go down here and go, okay, 46 minus 12 times 10 should also be negative 78. Oh, but I forgot. Oh, up here I forgot the plus 4. Up here I forgot the plus 4. That's a big, huge mistake. That's why we're off by 4. I should have put a 4 plus on this because that was the entire thing. And there you go, negative 74. Forgot that. That would have been kind of scary. So, all right. Strong correlation. If you remember correctly, strong linear correlation has... I'm not sure why it's doing that. I'll go back to this. Okay, maybe I can draw now. If you remember, strong linear means we're going to be close to 1. I don't know why it's erasing. So you're gonna have to listen to me because on this page it's not going to work. So we're going to want it to be close to 1 without going over. So in this particular case, we can't choose choice 3, even though that's the closest value to 1 because it went over 1. It can't be over 1. So we have to choose choice 1. It's the closest one that's positive. That's got a correlation that's close to positive, and it's close to positive 1. Excuse me. All right, let's see if I can draw on this one. Now go to stain. Okay, which problem involves evaluating 6p4? So what this is, it's 6 things, and you want to pick 4 of them where order makes a big difference. You're not doing combinations. Combinations are things like committees or teams or groups. Permutations are when order matters. First place, second place, third place. So how many 4-digit ID numbers can be formed using 1, 2, 3, 4, 5, 6 without repeating it? So the numbers 1, 3, 6 and 4 is different than 1, 3, 4, and 6. It's the same numbers, but it's a different permutation. So that one looks like it's right. Choosing subcommittees. Subcommittee is the key word for combinations. How many different outfits can be made using 6 shirts and 4 pairs of pants? Well, you're not going to take 6 shirts and pick 4 pants. That doesn't even make any sense. And how many different ways can 1 boy and 1 girl be selected from a group of 4 boys and 6 girls? Well, does that mean we're going to have 6 girls, and from those 6 girls, we're going to choose 4 boys? Doesn't make any sense. So choice 1 is the only right answer. All right, so what you need on this one is you need the center. So that's the first thing you're going to need, and that center is -3, 1. So it can only be, remember, when you put the center in, it goes in backwards. It can't be 1, and it can't be 3. Those don't make any sense. The next thing I need to do is, if you remember correctly, the formula for this is the x's squared plus the y stuff squared equals the radius squared. And we already now know that it's x plus 3 squared with the x stuff. The y stuff is going to be y minus 1 squared. But we need to know what the radius squared is. And you can't guess. You must show this by picking a point that is actually on the radius. I need to know that distance. And I do this by using the Pythagorean theorem. Very quickly, this is 3, and this is 2. So 3 squared plus 2 squared equals the radius squared. Well, isn't the radius squared what I'm looking for? Sure is. 3 plus 4 is 13. Or excuse me, 9 plus 4 is 13 is equal to the radius squared. That goes in the formula. Choice 4 is the right answer. And we're done with page 7. Moving on, kids. No problem. We got 19. All right. So we're going to replace x with 3i. We're going to replace y with 2i. And we're going to squared. And we're going to replace z with m plus I. All right. So not a lot to do here. This is 3i. This is 4i squared times m plus I. We're getting close. 4i squared is really -4 because I squared is -1. So this becomes -12i times m plus I. Well, that gives me 12mi plus 12i squared. Well, how many 12mi's do I have? 2. Now, this is really -1, so this really is -12. So what I have here is -12 plus 12mi. Oh, let me go back. I made a mistake. I apologize. It's early. I'm a little brain dead. I just said it was -12. I wrote down 12 for some reason. Some of you are probably like wondering what the heck I'm doing. It's really, this work right here is -12i. So when I distribute that, I get -12im minus 12i squared. Now, we just set it up. I'll say it again. I squared is really -1. So this thing becomes positive 12. So my final answer is 12 minus 12im. And that's choice 3. Okay, so let's think about this. Angle terminates in quadrant 2. So everything's positive here. Let's think about what's negative here. Sine is positive. Cosine is negative. Well, if sine's positive, then cosecant is also positive, and secant is negative. So now I want to figure out what they have here. Oh, the other thing is, since sine and cosine are both positive negative, I know that tangent is also negative in this quadrant, which makes cotangent also negative. Okay. So we're in quadrant 2. If cosine is negative, that works. Cosecant is negative. That's what this says. Nope. Sine is positive. Check. Cosine is positive. Nope. Can't be that one. Cosecant is positive. Check. Cotangent is negative. Check. That looks like it. That looks like our right answer. Check it with the last one. Make sure I didn't make a mistake. Tangent is negative. Check. Secant is positive. Nope. There we go. Done. Okay. Common mistakes on this one. Log. This is really 4 times squared. The squared is only with the m. If you remember correctly, multiplication comes from addition when you're working with logarithms. So this is really log 4 plus log m squared. But if you'll also remember, squareds or exponents come in front of the logarithms. So this should be log 4 plus 2 log m, choice 3. Moving on. Now, when I first saw this question, I'm like, there's no triangle. What's going on here? Why don't they have a triangle drawn? Because you need to draw it. You need to create your own triangle. P, Q, R. And P is right here. Little p is right here. Little q is right there. And little r is right there. Remember, capital R's for the point, capital variables for the points, and little r's for the vertices. I want to know what P is equal to. Let me go through my law of sines here real quick. A law of sines would say sine of R over R is equal to the sine of P over P, which is equal to the sine of Q over Q. We're going to end up cross-multiplying, and we want to see if we can come up with one of these answers. So this first one has R, P's, and Q's. Not really going to work. What we want to do is, you can't have all 3 letters in there. You can have 2, but you can't have all 3, because we're going to use any 2 of these to do some cross-multiplying. So I'm going to eliminate that one right away. You'll see when we get to the right answer. This one has 2. This one has 2, and this one has all 3. So I'm going to guess 4 is not it. So it's going to be one of these 2. So let me cross multiply. Oh, by the way, this should be in sine of R. Let me cross multiply with this one, just this one right here. So I get P times sine R equals R times sine P. If I divide by, if you want to know what P is equal, I divide by sine R. So I get P is equal to R times sine P over sine R. Oh, there it is right there. Done. I think you should be able to know a lot about angles. I'm pretty certain you can type this one in your calculator and get it. Let me go. I'll do that at the end. So what this says is the tangent of some angle is going to be equal to the square root of 3 over 3. And my kids are going to have to memorize that the tangent of 30 degrees is the square root of 3 over 3. So what I really want to know is arc cosine of the square root of 3 over what is really going to give me 30 degrees. So what it's saying is, really what this is, when you have an arctangent, we're really trying to figure out what's the angle measure that's going to give me the square root of 3 over 2. Oh. I lied like a dog on that one. I already know what the answer is. What I want this to be 30 degrees. So the cosine or the arc cosine of what will give me 30 degrees over 2. Now, you should be memorized. You're probably, you're working with cosine or whatever, you're going to be doing either the square root of 3 over 2 or 1/2. I guess I would have tried 2 first on this one. But the angle whose cosine is 3 over 2, well, that angle is 30 degrees. That will give us that. So square root of 3 over 2 is our answer. It goes in. So we want this to turn out to be 30 degrees. And the only way for that to be 30 degrees if you're taking the arc cosine of square root of 3 over 2. So the answer is choice 2. And I believe you could check this. Arc cosine is the same as the inverse cosine. So we'll do the tangent of the inverse cosine of the square root of 3 over 2. And then you have to figure out what the square root of 3 divided by 3 is, and it should be 0.577. There you go. Ow! Leg hurts. Same answer. That's the trick question, the tricky question. All right, moving on. We're almost done. I think what I'm going to do on this question is just rewrite these first. So I'm going to move my negative exponents. Negative exponents have nothing to do with being negative. They only have to do with being reciprocals, or, movement. We're going to move these. These x to the negative 2 really belong down here. Remember, x to the negative 2, which is really x over 1, really you're just going to take the reciprocal of this and change that to a positive exponent. Y to the negative 5, that's got to come up here. Y to the negative 2, oh, but it becomes positive. Y to the negative 2 comes down here, and it becomes positive. Now I can simplify it. 2 goes into itself once, 2 goes into 4 twice. Nothing to cancel with the x's. These 2 y's cancel with 2 of these y's, leaves me 3. So I have y cubed over 2x squared. Choice 1. Moving on. So we have to rationalize the denominator. So they gave you a kind of a tricky one. You're going to multiply by the conjugate, which is the same exact fraction as the denominator, but with a plus sign. Now, I teach my kids when you multiply by the the conjugate, you don't really have to do all of the double distributing. And I'm going to just do this for now, just in case I can simplify for later. So I'm going to multiply these 2 together, and I get x squared. I'm going to multiply these 2 together, and I get minus x. I don't have to do all the double distributing because the 2 middle terms are going to fall out. They'll just cancel. Don't do something stupid. That's got to be in parentheses, but I can factor out an x, and I'm left with x minus 1. Now this x will cancel with this x. So I'm left with x plus the square root of x over x minus 1. Choice 4. Moving on. All right. We got a common ratio here. So I got to figure out, first of all, how do I go from 1/64th doing something to it that I get negative 3 over 32. And then doing that same thing, I'm going to get 9 over 16. Well, let's see. If I multiply this by negative 3, I can't multiply by negative 3 because that would give me negative 3 over 64. That's not going to work. I need to divide that by 2. So here's what you got to do. You got to figure out 1/64 times some value is going to equal negative 3 over 32. Well, in order to do this, we're just going to multiply by the reciprocal. 64 over 1, 64 over 1. Goodbye. I get x equals, this goes in here twice, negative 6. So negative 6 is going to be part of my answer. So I know it's not choice 1 or choice 3. All right, so I took care of that part. Now what did I do? I got rid of 2 A's but added a B. So I'm going to get, in order to get rid of anything, that's got to go in the denominator. I'm getting rid of 2 A's, so I'm going to divide by A squared, but I'm getting a B, so I have to multiply by B. And so that's why choice 2 is your answer. And then they decided to end with a very difficult question, I think. K, L, M. K, little l, little m. LM is 13. Angle K is 40. KL is 20. And I want to know the measure of angle M. Well, I can simply do the law of sines. Sine of 40 over 13 is equal to the sine of M over 20. And if I cross multiply, I get 20 times sine 40 equals 13 times sine M, and then I just divide by 13. So if I do that in my calculator, the sine of 40 times, I think it was 20, divided by 13 is 0.9888. So I get sine of M is equal to 0.9888. So you need to do the inverse sign to get M. So you get M equals, and we'll do the inverse sign here. Tangent sine of the answer, control negative, and you get 81.45 degrees. So 81.45 degrees. Now, if you are just an untrained, very immature student, you will immediately pick choice 1. It is not the answer. And I will tell you why. This is one of those how many triangles can you make questions, but asked in a different way. So I've got 40 and I've got 81.45. That's 121. So it leaves us about 59 degrees for the last angle. But if you remember correctly, 81.45 degrees is right about here. That's the reference angle. But I could also do a reference angle of 81.45 degrees here, because that also is equal to this 0.988. So really what I have to do is I have to take 180 and subtract off this 81.45. Well, that's going to give me like 99 or 98 degrees. Let's say it gives me 98. So if I take the 40 and I add in the 98 degrees, that's about 138, which leaves me plenty for a third angle. So I can make 2 separate triangles from this one. measure of angle M. So I can make two separate triangles on this one. So it's the ambiguous case. It's ambiguous, choice 4. It's interesting, though. I think the answer still could be between 0 and 90 both times. But it is ambiguous.